Hello children, let's understand a very important topic of the chapter. It is Dalton's atomic theory. Children, Dalton was the first chemist who actually explained about the properties of atoms. Yes, so what were the postulates of his theory? Let's discuss one by one. So the first and most important postulate he proposed that matter consists of very tiny particles, and these tiny particles are known as atoms, which participate in a chemical reaction. So what he said that atoms actually participate in a chemical reaction. Then he further said that atoms cannot be divided further. Yes, they can neither be created nor be destroyed in a chemical reaction. He said atoms of a given element are identical in mass and chemical properties. Means if there are atoms of same element, same element or a given element, definitely it should have same atoms which have same properties and same mass. So they must be identical in mass and identical in chemical properties. Now the next postulate, he said that atoms of different elements have different masses and chemical properties. Means if we talk about different elements, their atoms must have different masses and they must have different chemical properties. The next postulate, the fifth postulate, he said was atoms combine in a ratio of small whole number to form compounds. Sixth postulate, he said relative number and kinds of atoms present in a compound is constant. Means in a fixed compound, there must be fixed number of particles present. That's why they are constant. For example, when we talk about water, we know that in water, particles are in fixed ratio, that is H:O, it is 1:8. That's why it makes H2O. So this example clarifies that atoms combine in a ratio of small whole number. What is that ratio? 1:8. Further, it clearly proves that if you are talking about water, does water always has H and O? Yes, that's why it will make H2O. So the relative number and kinds of atoms present in a compound is always constant, right? But so there are failures of Dalton's atomic theory, children. Yes, there are few points which were not appropriate because we actually found that atoms can be divisible. Yes, you heard it right. Atoms can further be divided into 3 subatomic particles, and those subatomic particles are electrons, protons, and neutrons. Right? Then atoms of certain element exist as isotopes. So children, what are isotopes? Isotopes are the atoms of same element, because we were talking about same element in Dalton's atomic theory. What was the postulate? He said that same atoms of the element must have same masses, but that's not true. There are atoms which are known as isotopes. Isotopes are the atoms of same element, but there is a twist. They are the atoms of same element, but they have different atomic masses. Yes, there is a possibility of different masses. How? Let's take an example. So when we talk about isotopes of hydrogen, children, do you know the atomic number of hydrogen is 1? So it has 3 different forms of hydrogen. There is hydrogen with atomic mass 1, hydrogen with atomic mass 2, and hydrogen with atomic mass 3. Yes, so they are different, but they all exist. When the hydrogen which has 1 mass, we call it protium. Hydrogen with 2 mass, we call it deuterium. And the hydrogen with 3 mass, we call it tritium or tritium. So the point to be noted here, they all have same atomic number, It has atomic number 1, 1, 1. But they have different masses 1, 2, 3. So it means the postulate given by Dalton was not appropriate, that all atoms of same element must have same masses. They can have different masses 1, 2, 3, and such atoms are known as isotopes. So it is an exception to Dalton atomic theory. I hope you have understood. Thank you.